All right, Chapter 2 study guide here. We're working with linear higher order differential equations. So this is an example of one right here, which we want to find the solution for. Remember, this parentheses of the 3 means the third derivative. So this says the third derivative of x plus 8 times the second plus 25 times x prime is equal to 0. So you should know that we need to create what's called a characteristic equation. So we do r cubed plus 8r squared plus 25r equals 0. The order or the degree of this thing always matches the order of that. You should know where that comes from. But from here, what we want to do is solve for our r. So I look at this and I say, oh, look, I can factor an r out. R squared plus 8r plus 25 equals 0. This definitely gives me r equals 0. But then I have to go and decide what to do with the rest of it. You may look at this thing and say, let me try to factor it, but you're going to run into trouble. We can't factor it. So I'm going to look at this thing on its own and complete the square on it. So r squared plus 8r plus something. What do I need there to have it be a perfect square? It's going to be r plus 4 squared. So I need a 16 there. And then there's a couple ways to do this. I'm just going to say, let's move the 25 over, so minus 25. And then I added 16, so we're going to add 16 to both sides. So what does that give us? R plus 4 squared is what that factors to, equals, all right, this gives me a minus 9, which is nice because when I can square root it, I get r plus 4 is plus or minus root 9 with a negative. That root 9 is going to turn into, or so the root negative 9 is going to give plus or minus 3i. So that gives me r equals minus 4 plus or minus 3i. So remember, I had a couple different r's here. I had r equals 0, and then these two r's. So those are going to become my, the piece of my equation, those are going to become what I do my e to the with, okay? I'm going to go ahead and write it, and then I'll explain where they come from. X is C1 plus e to the negative 4t, open parentheses, C2 cosine of 3t, plus C, over a little bit, 3 sine of 4t. So let's talk about where these come from. Oops, get out of here. All right, r equals 0. That's the one that gives me this. If I had r equals 7, I would do e to the 7t times the c1. But I don't have a 7. I got e to the 0t. E to the 0t is the same as e to the 0, which is just 1. So that's why this one gets a c1 with no e to the in it. You should know that the real part of this, the negative 4, gives me e to the negative 4t on the outside. And then the plus or minus 3i. And then this next thing comes from Euler's formula. Turns into C2 cosine of 3t and C3 sine of 4t. There's some math into showing why we can go from the plus or minus 3i to the sines and cosines. But it's pretty standard once you get used to solving these things to say, oh, when I got these roots, well, the imaginary part, which is the plus or minus 3i, gives me, oh, not 4 here. Come on, man. 3t. The imaginary part, which is the plus or minus 3i, gives me sines and cosines with 3's in them. And then the negative here gives me this real exponential decay piece. All right, that's it for this one.